Both HashMap and ConcurrentHashMap class implement the map interface via class hierarchy. HashMap directly extends from abstract map. ConcurrentHashMap directly extends from abstract map and implements concurrent map. HashMap iterators are fail-fast. ConcurrentHashMap iterators are fail-safe. Let us consider this with an example HashMap. Add 3 key value pairs to the HashMap: 1 mango, 2 orange, 3 guava. Now let's print the elements of the HashMap and run it as Java application. As you can see, the 3 values were printed. Now let's try to add 4th element to the HashMap while the iteration is going on. Now let's surround this with a try-catch block. Run as Java application. You will get a concurrent modification exception. HashMap iterators are fail-fast, and you get a concurrent modification exception if you try to modify the HashMap while you're iterating through it. Now let's consider a concurrent HashMap. Here we have added 3 key value pairs to the concurrent HashMap. We are modifying the concurrent HashMap while the iteration is going on by adding 4 apple key value pair. Now let's run this as Java application. As you can see, no exception was generated and all 4 key value pairs were printed. Concurrent HashMap iterators are fail-safe. HashMap allows a null key and multiple null values. Concurrent HashMap does not allow null keys or null values. Now let's consider this HashMap. There are 3 entries already present in the HashMap, and we are adding null keys and null values to the HashMap. Let's run this as Java application. As you can see, key is unique. The latest put value corresponding to the null key was printed, and multiple null values that we inserted were printed with their corresponding keys. Now let's consider the concurrent hash map. We have already added 3 entries to the concurrent hash map. 1 mango, 2 orange, 3 banana. Now let's put a null key and a null value in the concurrent hash map. Let's surround this code with a try-catch block to capture any exception. Let's run this as Java application. As you can see, we got a null pointer exception when trying to add a null key or a null value to the concurrent hash map. Null keys and null values are not allowed in concurrent hash map. HashMap is not thread safe as it does not implement any concurrency control mechanism versus concurrent HashMap is thread safe using gas and synchronized. Now let's consider this HashMap. Fruit list variable contains a list of fruit names. We have a fruit task where we are going to put 1000 random fruit values with unique keys inside the map. We have 2 threads T1 and T2. Both will run the task T1.start, T2.start. Let's run this and see what the result is. The expected size of the map was supposed to be 1000, but simultaneous access by T1 and T2 left the map in an inconsistent state. This is because the put and rehash operations of HashMap are neither atomic and nor they are protected by concurrency control mechanisms like synchronized. Hence, this can lead the HashMap to an inconsistent state when simultaneously accessed by threads. Let's consider the same example of the concurrent HashMap, that is the fruit task. Like in the previous case, in the concurrent HashMap, we are inserting keys from 1 to 1000 with random fruit values. So as keys are unique, 1000 should be the result. So the expected value of the map was 1000, which was correctly printed. Concurrent HashMap uses compare and swap and synchronize as concurrency control mechanisms, even when 2 threads simultaneously access the concurrent HashMap. As the concurrent HashMap was thread safe, the final result was 1000 entries were inserted into a concurrent HashMap, and hence the size was 1000, which was correctly printed. HashMap uses an array of buckets or nodes to store its key value pairs. Once you get a bucket index, the node is inserted into the given bucket. In case multiple keys hash to the same bucket, HashMap uses a linked list for collision handling. But for high number of collisions, the lookup time can degrade to O of n. So from Java 8 plus, red-black trees were introduced, so that a linked list is converted to a red-black tree in case of high number of collisions on a single bucket. Worst case lookup time of red-black tree is O of log n, which optimizes the complexity. HashMap has a default load factor of 0.75, after which rehashing happens. Concurrent HashMap uses the same concept of linked list and red-black trees as HashMap to handle collisions. It guarantees thread safety using concurrency control mechanisms like compare and swap and single list. It gives high throughput in multi-threaded environment as it uses bucket level locking. Thanks for watching. Please like and subscribe.